Okay, so we just figured out how to calculate the difference in arrival times between the P and the S wave. And we came up with 148 seconds for that, using those two methods that I described above there. So now, how do we figure out how far we are from the epicenter based on this difference of 148 seconds? So one way would be to use this equation right here where we plug in 148 for t, but this is a big pain in the butt and it requires you to type in a whole bunch of numbers. Again, if you have a graphing calculator, this can work fine, but a quick and easy way to do this is to use this graph. So let's take a look at the graph. So the graph has time on this side and distance over here on this side. We've got the P wave over here. The faster P wave covers a greater distance in a shorter amount of time than the S wave over here. So I labeled these. Hopefully you already figured those out. So how do we do this? So 148 seconds, this is how we do it. We take a piece of scratch paper like this, and then we come over here to the time scale and we put a little tick mark on our scratch paper at exactly 148 seconds. So I'm putting the bottom edge of my paper right here and I'm going up. Here's 150. So I'm going back just a little bit below 150 and I'm going to put a tick mark right here. And this distance now from here to the edge of the paper represents 148 seconds. From there to there. So now what we're going to do is we are going to slide this in between the two curves on the graph, okay? The S and the P wave. So I'm going to get this just perfectly vertical here, and then I'm going to slide it in between, and it looks like they're kind of touching right there. Look at that. So here's the top of 148, right about here. Again, I want to be perfectly vertical. Right here is the bottom. So now that's where 148 seconds fits perfectly in between the S wave and the P wave. Now all I have to do is go down here and figure out what that distance is. So each increment on this scale is 50 miles. So this is 500, 550, 600, 650, 750 right here. We're about halfway in between 700 and 750 miles. So let's just say it's about 725 miles. That's how we find the distance to the epicenter. So down here on number 20, for our distance, it'd be about 725 miles. Okay, so now that we figured out the distance to the epicenter from LA, 725 miles right there. Now we got to come over here to this map on page 6 and figure out where the epicenter is. So we're going to have to triangulate. Now we only have one distance, 750 miles. So here's Los Angeles right here, Houston, Boston, Chicago. All of the other cities are on here. But let's just do the LA location. So down on the bottom here is a scale that shows the distance in miles. So what we want to do is take a compass, this guy right here, if we have one, and put it right on the 0 and then adjust it so that you're right at 725. So here's 600, here's 700, there's 800, so about a quarter of the way up, that's about 725 right there, okay? Somewhere right about there. So with that, what we want to do now is put this part on LA, and we're just going to draw a circle with our compass, okay? And you don't have to draw the circle all the way off the map. The epicenter will be on the map. So we do that. Now we know that the epicenter is somewhere on this circle. So once you figure out the distances to the other epicenters, do the same thing. go to Houston, figure out how far you are from the epicenter in Houston, adjust your compass accordingly, and then draw that in, and where the circles all intersect, that's going to be your epicenter. So here, this is going to be kind of a low budget method if you do not have a compass, okay? The compass is the way to go. Go to Walmart, pick one up if you can. They're only a few bucks. But if you're pretty crafty, I'm not very crafty, but if you are, you can use the string method. So you could do it this way if you really have to. You could say, okay, I tied a piece of fishing line onto a pencil right here. So what you can do is put one pencil with fishing line duct taped to the bottom of your pencil here, and then I go out with my other pencil to exactly 725 right there, and I just kind of, oh man, this is not the way to do it, but if you really have to, you can do it this way. So there's about the same thing. I come here and I can draw my circle using the string. Okay? So again, if you are confined to your house and you can't get out, you can't buy a compass, maybe you can find some string and two pencils and you could try to do it this way. All right. More to come. You ready? All right. So let's take a look at number 22 next. At what time did the earthquake occur based on the LA data? Show your work. Wow, this looks like it might require supernatural math skills, but it doesn't. It's just subtracting. So let's review what we know. The earthquake was 725 miles away from Los Angeles, according to our data. But up here, it says that the P wave arrived in LA at 10:40:15. So 10:40:15, that's the time of day that the P wave arrived in LA. So let's try to figure out how to find the exact time that the earthquake occurred. So what we need to do is find out how long it takes a P wave to travel 725 miles. And then we need to subtract that time from the P wave arrival time here at LA of 10:40:15. So all I have to do here on the graph is say, okay, here's 725. I just come up until I hit the P wave, which I already put a little dot on there. It's right there. So now I need to just come across this way to figure out what the time is, and it happens to be 155 seconds. So what I need to do now is here, I'll turn this around for you. I need to take this time, which is when the P wave was felt in LA, and then subtract off 155 seconds from that time. Okay? So, wow, what's 155 seconds? Well, it's 2 minutes is 120 seconds. And then I've got to tack on some more time for that 55. So that's going to be an extra 35. So 2 minutes and 35 seconds is what I have to subtract off of this time right here. Okay? So what do I do? Well, let's start with going back 2 minutes. So if I take 2 minutes off of this time, that puts me at 10:38:15, right? So, but I need to get rid of this 35 seconds, so I need to go back another 35 seconds from here. So what's that going to do? That's going to put me back at 10:37. Well, 30 seconds back would make it 10:37:45. but it's 35 seconds, so I need to take another 5 seconds off that. It's going to be 10, 37, 40. That is when the earthquake actually occurred. Okay, so we got the time that the earthquake happened, 10, 37, 40, right here. We just calculated that. That's going to go right down here on number 22, 10, 37, 40. And what's really happening is this. So the earthquake happens somewhere on this curve. Let's just say it happens somewhere up here. So at 10, 37, 40, there was an earthquake. And then the clock started ticking and the P wave started heading for LA. And 155 seconds later, the P wave hit LA at exactly 10:40:15. Does that make sense? All right. So now for number 23, we're going to do exactly the same thing, only with the Houston data. Okay? We're going to use this same exact methodology. And when you come up with the time for 23, what should it be? Well, the earthquake only happened at one time. It couldn't have happened at two separate times. So this number and this number should be pretty close together. It might not be exact because we're using a graph and there's some room for error there, but it should be within about 15 seconds of your LA data, if not even closer.